Hello, GM, Arvinauts, and yeah, welcome back to a new live stream with Arbitrum and Alchemy. Today is a great Thursday, and yeah, sunny Thursday for me. Hope for you too, and yeah, for some maybe it's Friday. But yeah, today we are going to be learning more about account abstraction, and yeah, this is something that is improving the user experience. The user experience for a better onboarding into the Web3 ecosystem. And yeah, this is the workshop number 4. And today is Dan Nolan with us. So yeah, super excited to have you here, Dan. Thank you. You are famous now for sure for the Arbitrum community. You've been here during the whole series. So yeah, super excited to have you back for sure. And yeah, today we'll be learning about account abstraction and embedded accounts. And yeah, I think this is super important to learn because with this, now you'll be able to ship an app with built-in modular accounts for your users, and you're going to be able to tie it to their email addresses as a login. So yeah, at the end, a better user experience and a better onboarding, and an easier onboarding. But yeah, then, how are you today? Maybe you can give a brief intro about yourself. I know you're already famous, but yeah, maybe some people is the first time they see you. So yeah, can you share a little bit about yourself?
Oh, I'm very famous. That's good. Yeah.
You're the star.
Hey, everybody. It's me, Dan, again. So if you've been through the last 3 episodes, then you probably already gotten a little bit of my intro. Maybe I should have saved like another fun fact or something that I had for myself. I've mentioned in the last few episodes, I really love education in the Web3 space. If you watched the previous episode where we talked to Ryan from CyberConnect, then you heard a little bit more about my entry story into crypto, which was back in 2018. The original ETH Denver was like really my big event and intro into the space. And what I really loved about the space at that time was we didn't know what applications were going to emerge in crypto. We didn't know what Web3 was all about. And so we were all talking about it. And it was such a blank canvas that creativity was running wild. And some of the ideas were just pretty terrible, but some of the ideas, were really good ideas that people had that I haven't really seen come back, even though now you have chains like Arbitrum that are making fees so cheap. And we can actually start building applications that will make it so that our developers, or as developers, we can onboard users really easily, especially with account abstraction. So now that we're removing the UX hurdles and now that fees are super low on Arbitrum, you could deploy these applications that years ago we were just dreaming of, and now we can actually start to see them. So that's kind of the main theme of the discussion today, because I want to build for you guys an application, something that I would love to see really take off. So that if this inspires somebody to build something, I would love to see that. Please let me know if this is something that's super interesting to you, because what I'm going to be thinking about is how you would manage an inventory if you were going to be using a bunch of different NFTs across a few different games in the industry. So we're going to build that application using Alchemy embedded accounts and then deploying all of that to Arbitrum Sepolia. Cool.
Woo! That's super exciting, to be honest. And yeah, it's crazy how these kind of events change lives. Like you go as an attendee, and then you became a founder, or like Dan that is here, like part of the Alchemist team. So yeah, you can do a lot of things here. So yeah, super exciting for this one, Dan. And I know you have a very special workshop for us, like including with gaming. So yeah, let's get started. Thank you for coming by today.
Thanks so much, Anna. And something you said really resonated with me there too, is like a hackathon is such a great entry point into the space. Like for me, I mean, it was, we had so much energy coming out of that hackathon, and we were so, we were invited into the space to build something cool. And that's just like a really awesome opportunity to be able to get. And so I'm always on the lookout for things that I think that developers who are just trying to learn the space, uh, things that they can build, new things that we could build, new places that we could start to experiment in. And that's the theme of this application. Is I think it's something that you guys will be able to extend upon, something that you could pull down and play around with. So yeah, really excited to jump in. Let's go ahead and get started. I'll present my screen and we can get underway with this workshop. So here we go. Let me make sure I'm sharing my entire screen. Cool. All right. Do we see ourselves? We see ourselves. And now
yeah, I can add it to stage. Amazing. It's here.
Awesome. Cool. It's here. All right. Sweet. So I gave myself a little bit with just trying to keep to as good of a time schedule as we can here. What I'd like to do is take you guys through building an application with embedded accounts. And like I said, deploying it to Arbitrum Sepolia. I gave myself a little bit of a head start here with this application. So I'm going to walk you through some of the code that's already here, just because I didn't want to set up a lot of time just working through some configuration steps. But if you're interested in basically getting to the same point that I'm at, what I would recommend doing is going to accountkit.alchemy.com. And I'll say this again at the end. So in case you guys are watching and then you want to go check it out at the end, but you can go to this Alchemy signer, and basically this guide is going to walk you through all the code that I have inside of my repository, set up a little bit differently, only because I needed to do a couple things for the application. But we'll talk about what those things are, and we'll talk about what the Alchemy signer is more as well. So what I want to do first is show you guys what I have right now. So beginning this this live stream, this is what I have. That's a little bit of a head start. Is we have an email and a submit button that's basically going to allow us to log in as a user just using our email addresses, and that's going to automatically give us a smart account. So we talked about this idea of a smart account in previous episodes. A smart account is a smart contract that you can think of as your account because you can use a key to control that smart account, right? So traditionally we would have a smart contract, which you can't really think of as your account because you have to like use an account, an externally owned account, to control that smart contract, or you have an externally owned account that doesn't have any code, right? But in this case, we're going to log in a user with their email and just be able to start using their smart account right away, which is super cool. So what I did here is I found this cool service called Temp Mail. There's a lot of ads, so I apologize for that. But one thing that you can do is you can actually just sort of get a temporary email address, which is pretty cool, because that's what I need for this demo here is just a, let's start from scratch here, and we'll get a new email address. And I'm just going to sign up a brand new email address so that you know that I'm starting from scratch here. And that way we don't look through all of my emails or something like that. So I'm going to go ahead and pull this email over, and we can put it in here. And when we submit this, we're going to get an email that's going to come over here to sign into this game. So once we sign in over here, this is going to set me up with my account. And right now I have a really basic application that I just wanted to use to get us started. This address right here is my smart contract address. If I actually click on this, it's going to bring me to Arbitrum Sepolia. And it looks like I've used this account before because so maybe I need to get a new email. Let's see if we can do, let's delete this one and create a new one. Because that account was already used. So let's just make sure that we're starting from scratch here. All right, cool. There's a new one. Sweet. So I was testing this a little bit beforehand. So let's resend an email, and then we will get a new email over here, and then we'll be able to log in with that one. Awesome. Okay. So cool. Now I have a brand new smart contract address. So you kind of saw a little bit of the flow there, even though that wasn't intentional to get you familiar with it. But you could see that I could log out, I can log back in, and I get a different smart contract address. If I log in with the same email, so right now we have 0x87 F841. So remember that 87 F841. If I go back in and I log in with the same email, the one that I just logged in just a moment ago, I can get another email and then log back in. I'm going to have the same smart contract address. That's the way this application is set up. So hopefully we'll get this email in just a sec, and we'll get another notification here. And then we could log back in, and I have that same smart contract address. Okay, so basically what did we establish so far? We have an email login where your users can put in their email, they get an email, and then immediately upon coming into the application, they have this smart contract address. And what you can do as a developer is you can start to interact with that smart contract address. You can start sending user operations. And specifically in this application, we're going to be using a gas manager policy that is going to pay for all of the gas for us, so we can just start interacting with this application without having to worry about like paying for gas or setting up another key, anything like that. This is sort of just behind the scenes, but we're going to use this here to sort of track what's going on inside of this application. Awesome. So that's what we have here. So now you might be wondering, we see the smart contract address, we see the log out button, we know what that does. But now you might be wondering, why do I have box 1 and box 2 down here at the bottom? And the reason I have this is I want to have like a draggable drag and drop UI. So right now what it does is I have my face right here, where what I can do is I can drag myself into box 1 or box 2, and you can see that it's just basically saying dropped into box 1 or dropped into box 2, right? It can detect which one I was dropped into, and you can see that on the console there. Sorry, I'll zoom in a little bit more in case that's not easy to see, but you can see that on the console that I'm dropping my face into a couple different boxes. So what is the purpose of this, and what do I want it to become? What I want it to become is something that I've been thinking about for a while, which is this idea that if you had a bunch of games that wanted to coordinate on chain, over a shared set of resources like NFTs, and they wanted to say like these specific NFTs can be used in these specific games, then you would need something like an inventory to be able to track where those items are. If you only allow that item to be in one game at any particular time, which I think is a super cool use case, because what you can do is you can incentivize the game developers to coordinate such that when you move the item from one world to another, from one game to another, you can potentially pay the game developers of that game, incentivizing them to coordinate over a shared set of NFTs or resources. So right here, what I want to do is I just want to make it so that I can have an item. This is just a picture of my face. This is not an NFT or anything. This is nothing hooked up to the blockchain, but I want to make this an NFT. So I want to have like an actual NFT. I want to make it like a sword, like something that you would actually see in a game, and have that actually show up here. I want to see if there's a sword in this account, which right now there's nothing in here. This is a brand new smart account like we saw. I want to see if there's a sword in there, and then I want that sword to populate on this page, and then I want to be able to drag it between game 1 and game 2. And as a user, I don't want to have to sign anything. I don't want to have to pay for gas. I don't want to do any of that. I just want to be able to move my item between these different worlds. So that's the intention of this application, is to be able to get that going. So let's go ahead and dive into the code to see how this is working so far and what we have to do to get this moving in the right direction. So what I have over here is a very basic React app. Up at the top level, this is mostly what you're going to get when you go through the account kit documentation there, the quick start for the Alchemy signer. So I would follow along in that guide if you want to set up something similar to this. But essentially what we're doing is we're using the Alchemy signer here, and we set up a few things so that we can get that login, the email login set up that I showed you just a moment ago. For one thing, we're using Turnkey behind the scenes to manage the keys. So we're communicating through this Turnkey iframe container. So you're going to see that in there. And then we are also doing this login or sign up button, where when you click login or sign up button, we go to authenticate you. It sends the email, and then we come back in. And when we come back in, it's going to pull off of the query parameters the information that it needs in order to authenticate you, so we can actually be logged in and be able to control this smart contract account here. So that's basically everything in here. This is also going to set up the account so that once the account comes through, we can get it in this account component right here, which is going to show that account and give us that link so that we can go out to Sepolia Arbiscan and be able to see it over there, as well as this log out button. And then finally, we have this games UI, which is this drag and drop UI down here that I want to modify to be something that's actually doing something on chain. That basically is everything that we have here. There's a couple things that I have hidden away that kind of help me out here, which is the Alchemy signer configuration is set up over here. So this is we can configure a whole bunch of things about the Alchemy signer. We can pass in our API key. We can pass in the container ID if we needed to use a different container ID for the turnkey iframe. And then we could also pass in how long we want our sessions to be. In this case, I put them to be 2 hours. And then I have this smart contract account client. This is what I'm going to be using for all of our interactions with the blockchain. So when we need to figure out whether this user has an NFT, when we need to send a user operation to move that NFT from one game to another, I'm going to be doing all of that with this modular account Alchemy client. So basically what this is doing here is it's creating what's called a modular account. So a modular account is something that we've mentioned in previous episodes. It's this idea that you could have a smart account that can install plugins or little pieces of logic that allow you to do something with your account. So you can install something like a session key plugin if you want to have session keys that have limited privileges that only last a period of time. Or you could do something like if you wanted to have like a subscription. We just put out a video on YouTube for the Alchemy channel where you can learn how to build a subscription plugin if you wanted to let your users be able to subscribe to something. And you could build that logic into the account using this modular account standard. So this is creating a modular account, and then it's also creating a client that we can talk through in order to be able to do things like send user operations and be able to retrieve data from the blockchain. The other thing that you'll notice here is I set up this gas manager config. So this is going to handle the gas behind the scenes. So even though this account that I'm signed in with over here doesn't have any money inside of it, there's no ether, nothing to pay for gas, we're actually going to be okay because we're going to be using this gas manager config that's going to pay for the gas for us. So that is also happening behind the scenes there. And then you can see that I'm passing in the signer. The signer is the Alchemy signer that I talked about a moment ago, which allows us to be able to tie that email address to the user's smart contract account. And then finally, we're deploying this all on Arbitrum Sepolia. So you'll see me pulling up Arbiscan Sepolia specifically and seeing all of these things on chain. Great. So that's pretty much all the configuration, all of that out of the way. That's kind of all the stuff that you just have to get set up. But once you get set up, you're off to the races, right? What's really cool about this is we only have a few lines of code here that to set up all of this, just some basic React componentry, maybe some extra things for the query params and setting up the authentication. But once you have this going, you already have something where all of your users can log into something and be able to use a smart contract address. So let's go ahead and see what that would look like if we wanted to do something with this user. Now, what I want to do is I want to do everything on chain in front of you guys. So what I'm going to do next is deploy an NFT. So in order to do that, what I'm going to do is I'm going to pull up, I have this NFT storage window over here where I have some pieces of metadata and some images. I'm just going to close out of some of these tabs over here that I don't think I need. And I have some of these things over here. So what are they? So some of these are images. So if I click on this one, it's an image of a sword. And then this one is also an image, but an image of a different sword. And then we have two pieces of metadata here. So this is a metadata standard for an NFT. So if you're not familiar with this idea, basically there's a standard for what is expected when you go to fetch the metadata for an NFT. And in this particular case, it's giving a description and a name, and then it's also giving a link to that image, which this is the first sword that we saw just a moment ago. So you can see that we're actually linking out to that using this. So NFT storage is where I can store all these things so they can be stored on IPFS, and we can go ahead and be able to interact with these. Awesome. So what I'm going to do now is I'm going to mint this one. Let's do this one first. So this one's going to be the one that we're going to go ahead and mint. In order to do that, I need this metadata. So this is the thing that I'm going to need. So I'm just going to leave this over here. This is going to link to the image, and then hopefully we'll be able to see that in our application and also in like OpenSea testnet. So let's go ahead and try that out. So what I'm going to do is go over to Remix, and I'm just going to start a blank workspace because I already had some code in here. And let's just do a new blank workspace so that we don't have anything in here. We'll call this blank 2. Okay, so Remix is going to make it really easy for me to deploy some smart contracts. It's just the easiest way for me to get this going on the live stream and keep us in moving along pretty quickly. So what I want to do is let's call this like contracts. And then I'm going to create a sword.soul. And our sword is going to be an NFT. So in order to make it an NFT, OpenZeppelin has these great guides for getting started with all these different standards. I'm going to use ERC 721 for this particular case. So I'm just going to pull up this example here. And this looks pretty good, but you know what's annoying is like Google sends you to their older version, the 2.x, And I noticed that as I was looking down here, it sends you to 2.x. So you always just got to watch that because you want to get the latest versions on the latest versions of Solidity there. So we'll go to this one here and get ERC 721. And we can pull this on over into Remix. What's really cool is, oh, it's going to tell me don't copy stuff in here. But don't worry. We know what we're doing. So what we're going to do is we're going to go ahead and compile this. It's giving me an error because it says this is not being okay. Well, we can't do this import then. We just got to do that. Okay, that looks like it fixed it because that wasn't importing the ERC 721 namespace there. Okay, sweet. So once we have this in here, you can see that when I press save here and when I compile it, it's actually automatically, this is a brand new workspace, it's automatically pulling in everything that I need from opens up and contracts. That's some really cool magic that Remix does behind the scenes, which is awesome. So this is actually all wired up, and already I can compile this, and I'm getting no compile issues. This is actually pretty much everything I need. I actually don't think I need to change a thing about this NFT. I would say this is pretty good. We want to make it so that we can set the token URI when we award the item. We want to be able to mint it to a player and set a unique token ID every time. So I'm pretty happy with this example. So I'm just going to go ahead and run through it. So let's call this sword. And then we're going to go ahead and run that and compile it. And then we'll go ahead and deploy this and see if we can get it in that smart contract address that we have inside of our application. So let me go ahead and inject MetaMask here. And in my MetaMask, I am also connected to Arbitrum Sepolia here. So you'll see that I am, where is it? There it is, right? It's highlighted, so I'm connected to Arbitrum Sepolia. Great. So what I'm going to do is I'm going to go ahead and deploy this to Arbitrum Sepolia, this NFT. So let's go ahead and do that. And we'll deploy it. And then once it's deployed, we're going to go ahead and mint ourselves one at that address, the smart contract address that's tied to my temporary email address. So let's go ahead and do that. Here's the address. I'm going to pull it over. So there should be an award item function. Here it is right here. So I should be able to award to the player. The player in this case is my smart contract address. Again, you can think of this smart contract account like it's your account, right? For all intents and purposes, it is, right? You're controlling it with a key using all of the magic of account abstraction to be able to make that happen. So we have this player where we can mint to them some item. And then we also need a token URI where we can send the metadata through so that we can be able to pull this up to be able to pull the name, the description, and the image of the particular NFT. So let's do that. Here is my metadata for the NFT. I'm going to put it in the token URI here and go ahead and transact. So let's run that. And then hopefully we will have ourselves an NFT at that address. So this usually takes a couple seconds to mint and to show up on Arbiscan, but there it is. Very quick. Cool. So there's the game item. Unfortunately, it says game item. Did I not change the... I'm going to have to live with that for now. I didn't change it right here to say sword or something, but you know what? It's a game item, so we'll just roll with it. I'm pretty happy with that. So it says game item right now, and it looks like it's in there. It's a sword. If we wanted to test that this is the actual sword that I minted, we can go along to testnets.OpenSea, and they're usually pretty quick about indexing this stuff, even on the testnets, which is super cool. So if I go to this new smart contract address, there it is, right? There's our sword. So we have an NFT that we've minted to this account, which is super cool. What we want to do is we want to replace my face with the NFT. This is not an NFT, like I said. This is just an image. There's nothing Web3 about it. We want to actually read the user's inventory, what they have, what NFTs they own, and be able to show this here so that we can move it from game 1 to game 2. So let's go ahead and get that underway. So what I'm going to do now is I'm going to set it up so we can actually read the user's NFTs, how many NFTs they own, and actually start to show them inside of this application here. So let's do that. So what I'm going to do is inside of the account here, so this account component, and I'm super zoomed in, so it's a little tough to code, but hopefully this is good enough for you guys to be able to see. Inside of the account here, this is where we are setting up that link to the account address that takes me over to Sepolia Arbiscan. And then we also have the logout button here. And then we also have like the games UI. Sorry, I have a bit of cold, so sorry if I get a cool. So we also have this games UI here, and yeah, so this is going to set us up with everything that we need to do to be able to go from here. So what I need to do at this point is just be able to read the user's NFTs and be able to show them on the page so that we can actually move them from game to game. So what I'm going to do is, I said that I was going to use that client. So we have inside of our account utils, we have this get smart account client, and this is what we're going to use to interact with the blockchain. In all cases, it's going to represent our modular account, but also the interface between the blockchain for us. So that's what I'm going to do, is I'm going to use that. I'm going to say get smart contract account client, and that's going to go ahead and import it. But the other thing that I want to do is I want to do this. So when do I want to load the NFTs? I want to load the NFTs when the page loads, right? And specifically when we have an account address. So when that account address comes through, then I want to go ahead and fetch the NFTs for that user. So that's what I'm going to do, is I'm going to use a use effect. And, I'm kind of old school React. So if you see me do anything that's bad practices with hooks, do let me know, but it's something that I'm still getting used to be quite honest. But here we go. We're using a use effect. And what we want to do in here is we want to go ahead and use this client. I'm going to do an async iffy just so I can use await inside here, and go ahead and say const client is going to be await get smart account client. And this is going to go ahead and give me that client. So now what I want to do is I want to be able to grab the user's NFTs. And Alchemy, we have this really great NFT endpoint where you can just go get all the NFTs for an owner. If you're somebody who's tried to do that in the past without like an endpoint like this, it's actually quite hard to do. So this is really quite awesome that we can do this. So we could say something like, let's grab the tokens. Well, let's get a response first from our client, and then we're going to say .nft, and then we're going to say get NFTs for owner. I should mention, in case you're following along and going to run through this exercise yourself, the reason I have this .nft namespace and this method right here is because I've extended the smart account client with the Alchemy SDK API actions. So I actually also am using Alchemy SDK, which is going to give me the ability to be able to make these specific endpoint calls. So in this case, the NFT endpoint call, just in case you're trying to follow home and you don't have this NFT and namespace there available for you. So what we're going to do is we're going to go ahead and say account.address and pass that in. And if we get a response, so this should be awaited. If we get a response, then what we want to do is we want to go ahead and grab a token and then be able to actually pass that token down to our games UI. So that way we can render that instead of my face, right? So let's go ahead and do that. So I'm going to go ahead and create a token, set token, and I'm going to be a little lazy here. Like I said, this is going to be a pretty simple implementation. I'm just going to assume that the user only has one token for now, so we don't have to like write out the logic for many tokens and what that would look like. For right now, I'm just going to bother with just one token. So I'm just going to go ahead and say use state, and this is going to be either, so this will be either an owned NFT, which is something that we could pull out of Alchemy SDK coming from this endpoint here, or it's going to be undefined. And by default, it will be undefined. So we'll go ahead, and if we get a response back, then what we're going to do is we're going to say set token, and then we're going to set our token to be response dot. This should have owned NFTs on there, and then we should be able to grab the first one out of that. So because it's a brand new smart account, I'm only going to have one NFT in there. I'm just going to set that as our token, and that's going to be our NFT token that we're going to go ahead and pass down to our games UI. And I'll say token is equal to token. And hopefully if that all works out properly, we can go down into games now and we can set this up so we can grab the token as a token. I'm using TypeScript here, so I'm going to set up my types. You've probably already seen that, but owned NFT is going to be what I want there. And then I'm going to pass this token on down. So now what I want to do is this token is going to have an image in it. It's going to be that image that I put in the metadata. So what I want to do is I want to bring the image down here and replace my face with the image from this token. So I'm going to say token.image.original URL, and then we'll go ahead and pass that through. So if it's working, So for one thing, this token here, let's see what it's complaining about. Okay, so this token actually could be undefined. So that's a good catch by TypeScript, is that this could be an owned NFT or it could be undefined. If no tokens come back, right? If this user doesn't own any tokens, then when we index that 0 spot on the owned NFTs array, we're not going to have a token. So we want to make sure that we also just have that undefined. If it's undefined, then we also want to sort of conditionally render this image here. And this might not be best practice here, but this is what I'm going to do for the moment, is I'm just going to say, if we have a token, then go ahead and render our image with the token URL. So hopefully if this works, we should see a sword. Hey, look at that. All right, cool. I always love when it works. So the sword is there and it looks like it's working properly. And so instead of my face, we actually have an NFT represented inside of our application, and we could start to move that NFT around. So where's my console? Oh my goodness. I'm so not used to working in such a large, there we go. Okay. When it's like zoomed in like this, I'm like, how do I press buttons? Okay, here we go. All right. So down here is where I'm looking. What I want to do is I want to just be able to make sure that this still works, where I can drag into box 1 and box 2. Let's see. Is that not? There we go. Dragged into box 1, dragged into box 1, dragged into box 2, dragged into box 2. Okay, cool. So now we have an NFT that's represented on the page, and we're also dragging it into the boxes. Now what we want to do is actually use the smart contract account to be able to move it into not the boxes, but the games. So we're going to call these games, right? So let's change that immediately, because that's going to make it look much better, at least in my head, to call this game 1 and game 2, right? And then when we say dropped into box, we're going to call this game. And eventually I'm going to want to change this to be a game address. So the game address will be like maybe a smart contract, maybe just an externally owned account, whatever. But we're going to actually identify the games by an address. And that's how we'll identify them on chain as well. So we could drop this into a game. And now we should see that it says dropped into game 1, dropped into game 2. Okay, so now we need to actually do the core of this logic, which is actually making the user operations to move this item from game 1 to game 2. I don't have anything on chain right now that represents like game 1 and game 2. So I want to create something like a protocol that allows us to manage these resources, that allows us to say which NFT is in which game at which time, right? So that's the protocol that I want to build. So I'm going to have to go and build another smart contract. So let's go ahead and build a smart contract. Let's do that. So this is going to be some on-chain logic here that we're going to call, I don't know, game protocol.sol, right? So let's call this game protocol.sol. And what is game protocol going to do? So game protocol, I'm going to keep all this stuff here, but I am just going to, this is not going to inherit from anything, and we're good. I do think I'm going to, so for this game protocol, one thing that I'm going to need to do is when I move an item from game to game, I'm going to need to make sure that the user actually owns the NFT before I do that. So I'm going to want to use the IERC 721 interface. I believe it's at this location. Let's see. Yep, looks like it is. All right, sweet. So I'm going to want to use the IERC 721 interface so that we can actually interact with the NFT that the user specifies. So we'll do that. And so I'll leave that there. Now what I want to do is I want to build my storage. So what is this game protocol actually tracking at the moment? For this really basic use case, what I want to do is I just want to track NFTs to games, right? Where is my NFT? Which game is it in? That's really what I want to do. So I want to do some sort of like a mapping of an NFT to a game. Now, this is a little bit complicated, a little bit more complicated than you might think it is for an NFT, right? I don't know what the proper way to do this is. So maybe there's some Solidity experts out there that would say like, do this a little bit differently. But for me, the way that I would think about doing this is like an NFT is an address and a token ID, right? So it's a address plus a UNT 256. So I think what might make sense for us to do is sort of pack these together. And just in case, I'm just going to take the Ketchak hash of that. And that should be something unique because, you know, a token ID is unique for every address, and then address should be unique in and of itself. so that if we put these two things together into a check hash, we can have an NFT reference, something that uniquely identifies any given NFT in an ecosystem. The address itself is just a collection, remember. It's not the actual NFT. The token ID represents the actual NFT that a user might own. So we want to sort of map a NFT. I'm going to call it a bytes32 to a game. And the game is going to be an address. And you can imagine this game being like a smart contract, or maybe it's just an externally owned account. Maybe the game developers use this account to get paid because there's some sort of an incentive mechanism for game developers to interact with this game protocol, to put their games on this game protocol, right? Something like that. So we're going to go ahead and say mapping. We're going to map an NFT to a game so we know where that NFT belongs. And then we're going to call this something like resources, right? These are the resources that the game protocol manages. And then what we want to do is we want to write a function, and this function is going to move our item, and we're going to move it from, so first we need to specify the item, right? It's going to be a NFT address, which is a collection, token ID, which specifies the specific token, and then finally the game, right? And the game is going to be where we want to move the item to, and I'm going to make this external. And what we need to do first when we go to move the item is like what I was saying before with the interface, is we want to make sure that the item actually belongs to the user, right? We want to make sure that that ownership is still respected within our protocol. So the first thing that I'm going to do is I'm just going to require that IERC 721. So now I'm expecting that this address right here, this NFT, is an NFT, right? It might make sense to even have like a list of NFTs that your game protocol allows, right? And then you would first check that that NFT is allowed. But in this case, I'm just going to assume that this address is an NFT, which is fine, I think, for our use case right now. And then what I'm going to say is owner of, I believe, is, let's see, can we find this in here? IRC, this is a reference somewhere else. So here we go. I think we have owner of on IERC 721. Yeah, and then you can pass in a token ID, and then it returns an address, whether or not, who is the owner of it? Okay, sweet. So we're going to pass in the owner of the token ID. So this is going to return who's the owner of this particular NFT token ID. And we want to make sure that it's the message sender. So whoever's calling move item should be the person who owns it. In this case, for us, it's going to be me with my smart contract account that's already baked into the application. So we could just run a user operation through the application. Okay, so we'll require that. And now we want to actually move the item. To move the item, what I'm going to do is first I'm going to create this reference to the NFT. So to create the reference to the NFT, like I said, so I don't want to shadow this definition here. So let's call this like NFT ref. And we'll say check hash 256. And then we're going to ABI encode packed the NFT and the token ID. We're going to put those together and then check hash it. That should give us a unique reference to the NFT that should work within our protocol. So like I said, might be a better way to do this, but that is going to at least give us a unique reference to the NFT that we could use within our protocol to know that we're referencing that. So this is going to be the reference here. And what I'm going to do is I'm going to go ahead and say resources NFT ref is equal to this new game that's being passed in, right? That is moving our item from one game to another. Now we're basically saying this NFT is now mapped to this game. This NFT is mapped to this game. And if you're a game that was implementing this protocol, you could just use the blockchain sort of like a database, right? You could just say, where is the item? Does this user's item belong in my game right now, or is it somewhere else, right? And you could sort of just look that up at that point, which is pretty cool. And then the last thing I want to do here, sometimes it's a little hard to track user operations on chain. We'll see that in a moment. But the last thing I want to do here is I just want to create like an event that we're going to emit anytime an item is moved. And like I said, I just want to track that this is happening. So I'm just going to say item moved. And I'm not going to put any parameters in there. If you were actually doing this as a real world case, you might want to track all the parameters. You know, it depends on like what you expect people to use this event for. But in this case, I'm just going to use it to be able to easily look up the user operations that have happened on this contract. Okay, great. So that's almost everything we need. The only other thing that I need in this protocol is the ability to look up where the NFT is. So I could just make this public right here, this mapping public, but then client side, I need to come up with this Ketchak hash, the NFT reference, and that's kind of a pain. And I usually have to do a little bit of work to get the crypto to work the same way on the front end and the back end, with the Ketchak 256 hash. So I'm not going to worry about that. Instead, I'm just going to write a lookup function that's going to make it a little bit easier. So I'm going to do the same thing, token ID, address token ID. This is going to be an external view. And what it's going to return is it's going to return an address, which is the game that it's at. So we're going to find where the item is by calling this lookup function. And what we're going to do is we're going to take this NFT ref, same NFT ref, because we have the NFT and the token ID, and then we're just going to return resources NFT ref. Cool. All right. I forgot to put an emit there, showing my oldness with Solidity before emit used to be there. Okay, sweet. That's probably our protocol. I think that's all we need. So this is kind of tracking an NFT across many different games. So an NFT can only belong in one game at a time. And if you're a game that's implementing this protocol and you want to use it for some reason, maybe you're incentivized to do that, then you could just go and call this lookup function to figure out, does this player own this NFT and is it in my game currently, right? Awesome. Okay, so then what we could do is we could deploy it. So let's go ahead and deploy that, and we'll have ourselves a game that we could actually interact with, or a game protocol that we can interact with from our front end. How are we doing on time? Okay, we're running up on time. So let me make sure to get this in here. So we will deploy this. And this will come through. So there's our game protocol. So what I'm going to do now is I'm going to copy this over, and we're going to start implementing all this stuff. So the game is going to be at this address. And then, so this is going to be our game protocol address, right? Okay. And then we need a game one address, which is just going to be some address I come up with. Because I'm not going to do any smart contract logic for now for game one and game two, but I do want an address to represent these games, right? Because that's how we're going to keep track of which game they belong to. So for now, I'm just going to hard code that. I'm just going to come up with some random code, some random address for those games. So let's go ahead and do that. I'm going to use crypto, which is a library from Node.js core, and I'm going to say random bytes. And I'm going to grab 20, which would be an address. And we'll say toString hex. Yeah, sweet. Okay, so that's going to be our game one address. We'll make it 0x'd. And then we'll do this game two address. We'll do 0x there too. So there's game one, game two. There's a game protocol. What we need to do is when we drop this item, what we need to do is we need to actually move it into that world, right? So what we're going to do is we're going to use that client again, that client that I have in my account utils, to actually do a user operation that's paid for through that gas policy I was talking about earlier. And it's going to go ahead and move the item from game one to game two, or wherever we want to put it. So now we're actually going to be doing that, passing it to the game address. We need to actually plug in these game addresses here. So game address one is going to go in there. So it actually comes through when I drop it into these particular boxes here, the games. Sweet. So what I need now is I need my client. So I need to get, my client is going to be await get something client. What did I call it? Get smart account client. Oh man, get smart account client. That's going to go ahead and import it. That's going to get me my client. And then what I want to do with my client is I want to be able to interact with it. I want to be able to send a user operation. Unfortunately, there's a method called send user operation, which is very aptly named. And what we want to do is we want to send a user operation. We do have to put in this UO, which stands for user operation. And then we need to specify a target and then some data. So this is how we are going to specify our user operation. Now, I've talked about user operations in previous episodes. The idea behind a user operation is it's not a transaction. It's something that gets wrapped in a transaction. So you would send a user operation to a bundler. The bundler would take a bunch of user operations, put in a transaction. That goes to the entry point and gets sent out through your smart contract accounts. So this user operation is going to be paid for through that gas policy. But at the end of the day, you can think of a user operation very much like a transaction, in that we are targeting some address somewhere with some data and potentially some value. But in this case, we're not doing any value. We're not sending through any native currency, so we're not going to worry about that for this. So our target in this case is going to be the game protocol address. So we want to target the game, and then the data is going to be move item. It's going to be address, uint address, where the first address is going to be the NFT collection, token ID, and then the game address that we want to move to. So we do have the game address. It's right here. We're also going to have the token for the token information for the contract address and for the token ID. So we can get all of that. The problem here is that we do have to encode this into call data. So I am going to make use of something from Ethers here. So let's call this like game interface is await Ethers. So I do have Ethers installed, fortunately. So I could say ethers.interface. And we're going to pass in here. Now, what we need to pass in here in order to get an interface that's actually going to map this ABI properly to the call data that I want is I need to pass in the interface for the game. Fortunately, Remix makes this really easy for you to get the ABI. So I could just sort of copy this clipboard and we could just put this inside of our source here and call this like games.json. And then I'm going to go ahead and import that and say, and we're going to go ahead and import that and say games. Let's call this games ABI from games.json. And we're going to plug that into our interface. And this interface is going to allow us to encode that function data to actually use the call data that we want to here. So we're going to say game interface.encode. Where are you? Encode function data. I think that's the name of the function. No autocomplete, huh? Give me it. No? Okay. Oh, it's mad about something. What is it mad about? Type of interface is not called. Oh, oops. I didn't mean to say it. Wait, I meant to say new. I'm like talking too much and not thinking. Okay, cool. Encode function data. There it is. And what we want to do is we want to call move item. And then move item is going to take 3 arguments. Like I said, it's going to be the token dot contract dot address. And then it's going to be the token dot token ID. Right? And then it's going to be the game address that we're specifying through our handle drop function because we're going to be dropping it into either game 1 or game 2. What I might want to do here is you can see these question marks, TypeScript's putting it on here. I might want to just wrap this in, let's say if token and client. I expect us to have a token and a client at this point in the code. But I'm just going to wrap it in there so we can get rid of those and we don't accidentally send through something that's undefined. Cool. All right. So that should pretty much do it. It is giving me an issue here, which is, oh, this is a type error. So this right here is a string, but the UO wants it to be a hex string. So I just need to tell it that this is indeed hex string, which, you know, it's just prefaced with 0x. And I'm just going to kind of force that there. All right, sweet. So now we should be dropping the item into the game. And that's going to actually do those user operations. So now we can actually see that we're doing something on chain. So let's see that that's working. If it's working, so first of all, I expect no errors to come up over here. Come on, console, where are you? There you are. Okay, so I expect no errors to come up over here. The other thing I expect to have happen is when we go to the contract address, we should see some user operations, right? So, okay, we just dropped it into this game right here. And if I go to the contract address, here's the game protocol address on chain, what we should see is we should see some events, right? Well, one event specifically. This is the event that we programmed in, which is that move item. It's showing it in topic form. That's because I didn't verify and publish my smart contract address, but we only have one event on our contract anyway. So we know that this is the one that we expected, which is the move item event. So what that means is right now we are properly moving the item. So if I moved it into game 1, I would expect another event to occur back here. And there's my second event. So these are user operations that I'm actually kicking off by moving into these different boxes, right? And that's like a really nice user interface. I don't know. You gotta make it look nicer, right? And what a user might expect. But you could imagine like a game inventory that looks a lot nicer than this, where you just want to move where your items are. Like where does this item belong? Does it belong in game 1 or does it belong in game 2? And behind the scenes, something is happening on chain whenever we do this, right? We've sent three transactions that are actually moving this game from one place to another. Okay. Anna, I wonder if you're there. You can let me know if we can go a little bit over, but I can try to finish this up as much as possible. I think we're probably going to go like 15 minutes over the hour. I don't know if that's okay, but
Yeah, for me it's fine. And like, if you're okay with that, it's all right. No worries.
okay,
Like,
awesome.
people here are loving you. Like, they say, tell me, saying like, Dan casually jumping from Solidity to React to TypeScript like a boss. You're a machine, Dan. But yeah,
Oh,
yeah, you can go ahead for sure.
oh, that's great. Thanks for the enthusiasm, everybody. I'm glad that people are paying attention. It's hard, right? Like, you think you're just talking to like sort of a black box sometimes when you're doing this stuff, and it's good to know that people are out there listening and following along. So that's great.
Yeah, I know.
Awesome. Thank you, Anna. Okay, cool. So, all right, this is great because we're getting up to the really exciting part here, right? Right now, I mean, this is kind of silly. I'm just sort of moving this item from game 1 to game 2, but like, and these user operations are happening. Oh, maybe I did that too quick. We might have to control the nonce manually if we want to do things really, really quickly, or batch them together or do something like that. But you can see that I'm doing these user operations super, super quickly. So what we want to be able to do is actually represent where the item is, right? And what would be nice is if we could actually have this sword show up in the game that it exists in by going and looking it up on chain. And we can do that. So that's what we should do. So let's go ahead and do that inside of our games. Is we're going to use state. So we're going to say this is going to be the game address for our particular token, right? So we have one token, and then we're going to have a game address, and we're going to say set game address. And this is going to be use state, and this is going to be a string, and it's going to start out as an empty string. And I need my use state to come through. Okay, so we have a game address, and we're going to set a game address. And what we need to do is we need to go look this up on chain to see where the token is, which game is it inside of. But at first, I'm just going to set it sort of manually. And what we'll do is, okay, so this draggable icon right now is sort of just sitting in the one spot, but I want to make it so that it could live in game 1 or game 2. So I'm actually going to pull this component out, and I'm just going to say, let's just call this draggable. And we're going to leave most of this in here. So draggable is equal to, if the token exists, then it's going to be this image that we can move. So if we're not in either game, we're going to show it out here. But if we're inside of one of these games, then we want to show it here or here, right? And let's see how that looks in the UI. All right, so the game is showing up everywhere right now, right? But I want to show it where it actually exists. So what I need to do is I need to start first program in the React logic so that we can show it where it exists inside of a client-side logic. And then we actually want to read that from the blockchain so that we actually, treat it like a real Web3 application. So, all right, there is our game 1 draggable. What we want to do is we want to make the logic for where the game is. So is it in game 1? Is in game 1 would be if the game address is equal to game 1 address, right? So if it's in game 1, then it's there. If it's in game 2, then it's game address is equal to game 2 address. And then finally, if it's in neither, is in neither. You can see I'm doing this very rigidly, right? But if we had a lot of games and we had a lot of items, you'd want to compartmentalize this and really, abstract it out a little bit. But if it's in neither here, then we'll say neither is in game 1 or is in game 2. I always get worried about doing Boolean logic like that on screen. I feel like I'm missing something. It's in that or that, not either. Yeah, that's right. All right, so is in neither and draggable if it's in game 2 and draggable, and if it's in game 1 and draggable, right? So where is it? And initially it's going to start out not in either. So we should see it right here, and then we should be able to drag it into these and actually see it go through. So right now it's sending the user operations, which is cool. But what we also want to do is after we send the user operation, I'm going to be optimistic here and assume that this is going to go through. Again, like, you got to write all your good logic in here when you have a little bit more time. And this is just very bare bones. We're just running through it. But set game address to be the game address that's being passed in on this drop event. So we just want to pass that in. So now, at least client side, we should be able to see this sword like show up in game 1 and then game 2, right? I kind of move it back and forth. But what it's not doing right now is when I refresh the page and we re-log in, right? And it's not showing me where it is because it was last in like game 1, I think is where it was. It's just resetting it because client side, it's not looking it up. So the last thing we need to do is when this loads, when this comes in and we have all the things that we need, we want to do an effect that's going to go and look up where that item is, right? So let's go ahead and look up where that item is. So it's going to be pretty similar to this send operation. We're not actually going to be sending an operation because we're going to be doing a query. So we're going to need the client again. And so this use effect is going to need another async iffy. Again, not sure how good of a practice this is, but we will do that there. Is it happy with me? Okay. So instead of send user operation, let's do, it's getting mad because client could be undefined. Instead of send user operation, what we want to do here is we want to do core. This is coming off of the Alchemy SDK, core.call. And then we should be able to, similar to, this is going to be a query, more like a transaction than a user operation, right? It has the same parameters, but we're doing a query, so it's not actually making any changes on chain. But what we want to do is we want to send to, this will be to the game protocol address. And then the data is going to be very similar to this, but it's going to be a lookup. So let's do that. So instead of move item, this is going to be called lookup. And it only takes two things, right? Our lookup took the token contract address and then the token ID. And it's mad because also the token might be undefined, but I expect it to be defined by this point. So I'm just going to do that there as well. And that's all lookup does, right? If you remember back to when we created that lookup function, it takes an NFT and a token ID. It sort of mashes them together and then goes to look it up inside of our resources mapping to tell us where that item actually is. And so this is going to come back. This is actually going to come back as like raw data here because it's not actually interpreting this as like an address. And I want it to come back in as an address. So I just want to see what format this data comes back in first. So let's just log that out. So hopefully if this is working, it's going to show me the address of one of the games. And that looks like one of the games right here. So I have hot reloading going on right now. So this actually just came up, but just to prove it to you, like let's refresh here and then where's my data? Oh no. You know what? I think I probably have some dependencies in here that I should specify. What are they? Fortunately, VS Code is going to tell me what they are. Token? Yeah, that's a good idea. Okay, so if the token, there it is. Okay. So there's our address, right? ED1717. ED1717. So it's saying it's inside of game 1 address right now. But the problem is, like I said, this is not coming back formatted as an address. It's coming back formatted as a 32-byte value. So I do want to slice off the last 20 bytes or last 20 bytes, last 40 hexadecimal characters and be able to treat this like an address, right? So what we're going to do is we're going to go ahead and say address is equal to data.slice the last 40 hexadecimal characters. And then we're going to add a 0x to that. And that's going to be our game address. So we're going to go ahead and set the game address to this address right here. And I'm hoping that everything is all lowercase, or at least in the same case. It looks like this is a different case. Well, we'll hope that the casing is the same. I should probably like lowercase everything, but we'll just see if it works first. Well, it looks like it's working. The game 1. So now I just hot reloaded and we're in game 1, right? So it's putting it there. You could do a little bit better loading than showing the sword in the middle at first. It kind of like jumped there. But eventually it decided that it's in game 1. And if we moved it over to game 2, then we expect another user operation to happen behind the scenes over here, right? There's 1 second ago. And then if I refresh this, we should be in game 2. Yeah. All right. Now we're using the blockchain sort of like a database, right? We're reading where that item belongs and being able to like sort of look it up like that. So just to sort of like prove that everything is working the way I said it would, maybe what we should do is start with a new account. So I'm just going to run through this one more with a new account, but change none of the logic. So let's do this. So this smart contract account, like I said, is tied to this temporary email from this service. So if we wanted to delete this, there goes our sword forever, gone. We'll never have that email address again. So I'm going to get a new email address. What are these domains? And we'll log out here and we'll log in with this one. Email has been sent. So we should get a new email and we'll log back in with this person here. And we're going to get a new smart contract address, right? Fresh smart contract address right out of the gate. One thing I should mention, we talked about this idea of counterfactual smart contract addresses. This address right here is counterfactual. There's not actually a contract at this address just yet. We just know where it will be in the future. So you'll actually see that there's nothing here, right? So it's just, that's what the counterfactual means. Eventually we could put some smart contract logic here, but at the moment there's nothing. We're just like sort of targeting that address for the future place where all this stuff will happen for this user. So new user, new email, new smart contract address, no NFT, right? There's no NFT right here. What we need to do is we need to mint a new NFT for this user. So let's go through and do that. And this time, just to make it a little bit more fun, we'll use a different sword. So here's a different sword. When I think about games and like how they would interact over NFTs, these games would look different, or these items would look different in every game, right? And I think it would be up to the game developer to decide what that would look like. But you could imagine them still collaborating over a set of shared resources. So you could say that this is a sword that transfers between different games, and it might have different attributes in one game versus another game, and it might look differently, but it could still be your sword, and you could decide like where you want to bring it to, which I think is super cool. So here is our special sword. We're going to bring this back in here, and we are going to mint it to our player. So where is our, so here is the sword. No, here's the game protocol. No, yeah, it's the sword that we want to do it to. So we're going to award this to the player, and we are going to give it. So you could also imagine like awarding an item to players. Like, how would you do that? Like, what is the resource control of a game protocol like this? If you had a community that governed a whole bunch of resources and then the games that implemented these resources, it'd be something super cool. So the player that we want to mint it to is this one here, has no NFTs. So we're going to mint them a new NFT. We'll go ahead and transact that. Let's go ahead and do that. And then hopefully this will show up momentarily on Arbitrum Spolia. There we go. Sweet. So there's our game item. Again, I didn't rename it to sword, so it just says game item. And hopefully this will show up here momentarily. Oh, sweet. There it is. Okay, so there's our item. Now we have a new item here, and we could move that from game to game. And if we relog in with this account right here, we'll see that it's in game 1. We can move it to game 2. And yeah, that's, oh, it didn't move to game 2. Maybe the user operation was still going through. Oh, no. Maybe that one failed. See, you got to have some good error handling. All right, let's see if this one succeeds. Give it a second. All right, there it is. All right, so you got to handle the errors, right? I mean, this is very optimistic. We did all this very quickly. You still got to handle errors and everything like that. But at the end of the day, you can imagine UIs being this snappy with some good error handling and some good UI loading. You can make this look really intuitive to a user. And they could be moving their NFTs across many different games. And so like I said, in the beginning, if you want to build an application very similar to this, where you're using an email and you are signing in with a smart contract address, first of all, if you want to use smart contract accounts at all, definitely go to accountkit.alchemy.com and go to the documentation here and check out the account kit. If you want to use the Alchemy signer, like I did in this example, this is the feature that allows you to use an email and tie it to a smart contract address like that. And you go and get the email from your email address. This is how you would do that. So follow along in this guide, and it's going to teach you how to do all of that and set it up inside of your application. So yeah, that's everything. So I'll stop sharing here, and happy to take any questions if we still have some time there, Anna.
Nice. That was super fast, and wow, you're you're really a machine. But yeah, this is going to stay recorded for sure for all the builders that are here. So no worries, you're going to take your time here. But yeah, super exciting to see this. It was very cool, to be honest, and thank you very much. And yeah, well, I think there are no much, like there are no many questions. Like there was one question from Dorothy that said that what did you mean about setting the nonce manually?
Yeah, good question. So you did see a great question, Dorothy. So you did see at one point like there was an error that happened when I tried to drag the sword into the one box and then dragged it into the other game like very quickly. And so what I think happened there was so each user operation has a nonce, and that nonce is to help make it unique, right? Because at the end of the day, so we are still signing something as a user saying this is what I want to do. And whatever that thing that we're signing is, it has to be unique, because once you put a signature on chain, anyone could go and get your signature and then pretend to be you, basically being like, hey, this person wants to do this thing, right? So every single transaction and every single user operation across all blockchains have to be unique, because once they're on chain, they're public, right? So a user operation has this same mechanism for being unique like a transaction, which is a nonce. And a nonce is going to be an ID that's unique to every specific user operation and transaction. Okay, so you might have known that already, in which case I just gave you a little bit of rehash. But what I meant by that was that what might have happened is I might have dragged it in and then dragged it in again. And before it knew to increment the nonce on the first user operation, I already made the second user operation, and then it used the same nonce in both places, in which case one of those user operations was not valid, because one hits the chain first and then the other one is seen as invalid because you can't use the same user operation again. So I think that's what happened. So in that case, I might just, I might have to handle the logic if the user is going to be doing a lot of user operations super quickly, might have to do some manual nonce handling there at the application level.
Fantastic. Thank you, Dan. Yeah, and thank you, Dorothy, for the question. And yeah, like I think that's the only question we have. The other comments are like, "Thank you, Dan. It was really practical. The fire. It's great to learn about that kind of abstraction. So yeah, thank you, Dan. I want to thank you. It was a great session for sure, and and yeah, cool that you implemented like a gaming
Yeah.
experience here too.
Yeah, absolutely. Thank you for having me once again. And yeah, thanks for managing all this, and look forward to seeing you all back here for one more episode. So we'll see you guys back here for the fifth one.
Yeah, exactly. See you next week for the workshop number 5 with Alchemy and Arbitrum for sure. And yeah, thank you, Dan. I hope you have a great weekend ahead. And yeah, thank you everyone who joined us today. You're always super supportive. And yeah, see you soon.
Awesome. Thanks, Anna. Take care.
Bye, Dan. Thank you. Thanks, Al.